Hello, Nick here. I'm at the Vadnais Heights City Hall with my leaf pack setup, and I'm going to go over the training and the procedure for how to sort a leaf pack and convert it into data. This might look like a lot of stuff. It's a big workshop at first, but the process that is made by the leaf pack program is actually super simple and really helps you along with photo guides and an organization method. So the first step was to gather the pack. Obviously it came from elsewhere. This pack here in this bucket is from Lambert Lake. I took the pack, it sat for 3 weeks out at Lambert Lake, and once I collected it, I put it in this bag. This is a rather murky site. Not all leaf pack locations have murky water, but I'm going to be looking at what's living there by seeing what's in that. The first bucket gets sorted into a sorting tray. So I've got some fresh water here in this red bucket. I'm going to go through the leaves, look at everything, and then when I spot it, I've got some little tools, really techie sorting equipment, and I put it into each petri dish. The mayflies, the mussels, things like leeches, sow bugs, scuds are what I'm going to be expecting in murky water. I'm going to be using this area. I've got this little guide of photos, but the leaf pack program of course has the photo guide, laminated booklet, and the online resources too. So IDing the organisms is an ongoing learning process, but it's not very intimidating once you get going. Once you look at how many tails does something have, what's the body shape, is it a worm, is it a leech, is it a snail? Those things kind of fall into place. I like to use another additional ice cube tray just for sorting things out. When we have everything sorted, then that's the fun part. That's just a matter of filling in the data entry form. So I've got these on the Vlamo website, and it's made to mirror what is our data entry portal on the Monitor My Watershed site, and that's where the leaf pack location is placed on the map. So that site is going to take the data and spit out the assessment for the water quality index. You don't really have to do any math, anything with it. It's just a matter of getting the count and then entering it. So with that, we have everything we need to get started. I'm going to do that and then film a little later. So cool. Okay, so I'm just a few minutes in and I've already got 1, 2, 3, 4, 5, about a dozen samples. So I took the pack, I'm taking leaves out of it. Again, they're not always this messy. We take the pack and I place them in here. I take the leaves in the fresh water. Is there nothing else on the leaf? If so, chuck it. And then I like to fill this with fresh water every time I do a batch of leaves. And I keep doing that until the pack is empty, and I've basically just got a pile of leaves. So I've got dragonflies in here. I found a leech and a sow bug and some beetles. So that's a start. I'm going to keep going and we'll do an update in a little bit. But you know, when it comes to the ID, I should say, if you don't know what it is, that's okay. And we have resources, and the folks at the St. Paul Water Service are willing to help us out. So if you take a picture And if you get something in an extra petri dish, if it's unknown, try to just keep going through the whole pack, and at least you know, okay, what is mysterious and how many are there. As long as you know they look alike and they're mysterious and there's a picture, then the rest can work out later, because we'll ID it based on the best picture we can get, if it's zoomed in or if it's a small little detail, and then later we can always add to the data sheet, and we can wait to submit the data sheet until we really know. So there's time and there's resources there, that you're not at a dead end if there's a mystery. It's been about 25 minutes and I am now clear of leaves. I've got the leaves done, and I have taken the murky water that was in the bag and gradually just kept dumping it in my tray and diluting it with the fresh water. So I kept doing that until I'm out of water in the bag, and now I'm just finding the last ones that I might have missed, but I think I'm done and ready to count. A couple points of what I've observed is that every site we have has a specific organism called a water mite. It's so small, and it's basically a tiny dot that's swimming around. That's not even on the data form, and that goes to point out that, you know, if you don't know what something is, and if you take a picture, sometimes it's not even in the system. And that's okay, because the system is designed for what is going to be an indicator for habitat and water quality. Some organisms are common, yet don't seem to portray or indicate any kind of significance, whether it's clean water or dirty water or somewhere in between. So they just kind of pass it. There's a few beetles, and the water mites are an example of that. But the most common things, and I think what's confident to be able to focus on, is that what's pictured here is what you can sort, and at the end, if there's mystery, you know, deal with those at the end. But I've had plenty to work with. I've got beetles, I've got dragonflies, mayflies, actually more than I expected for Lambert Lake at a slow water, murky site. A common thing to notice is that damselflies and mayflies look similar, but damselflies have a tail that has depth. It kind of has a sail quality, whereas mayflies have a tail that's just a flat stick. There's 3 of them, and they sit flat in the water. So I've distinguished those, and actually, here I go. I'm going to switch one of these over, because that's the damselfly, not a mayfly, along with the dragonflies. So, obviously, I'm not here on site. I personally like to take all the organisms back to the water to let them live and let them continue on. You know, the leaf pack program, it doesn't really specify. It's not something you have to worry about whether, if you throw out all these organisms, it's sad. But generally in this field of macroinvertebrates, it's not an impact on the ecosystem. It's not doing a damage to those populations by taking this small sample. It's not like what you would see with larger things like birds or mammals. So with that, you can do what I'm doing. If there's a picnic table, set up a table on site. The North Oaks channels are great for this. Some of the places along Lambert Creek. If you set up something where you can do this on site, it makes it really easy to pour it all in a bucket and just take that bucket and whoosh, there it goes. I like to have this kind of bucket because there's a lid. So if I'm transporting things back to the water, it'll be in a lid and I can drive with it without it spilling. Same thing when I pick up the pack. I pick up the pack and like to scoop extra fresh water in with that. If you're going to try to let the organisms live, they're not going to like tap water and all the additives that go into that. So I recommend bringing some fresh water from the lake. Don't let everything sit very long because it'll get stinky. But like I said earlier, this is the murky site, and the North Oaks places, most of the Lambert Creek places, are less murky. And if it's less murky, it takes less time to analyze and sort everything, just because you can see it and it's easy. This was a good sample because I could tell the swimmers really easily. I knew where they were. The most putsy thing is when they're swimming around, it can be tough to scoop them up, to get them out, get them in their tray. The eyedroppers are a nice suction for the small things. If they fit, that's easy, you suck them up. And usually if they are tough with the spoon, they'll fit here anyway. And the bigger ones, if it's big enough, a spoon is easy. I think I'm gonna count this up and I'll show you the data form when I'm done. So, sounds good. Go. Cool, so here I am with the data form. I'll just go down what I counted. So this is the process that happens when we place the pack. We put the date down, so this started in 8/28, the time, one pack. We have a small thermometer that takes air and water temperature, so I marked that down. This was at a pool at Lambert Lake. Most of the channels in the watershed are actually a run. A run is just a clear shot of straight moving water, instead of a riffle that's, or something that has a rocky outcrop or texture, or more depth to the stream in terms of the interaction and the oxygen that is being exchanged because of rocks and ripples and basically if it's making sound, it's a riffle. But we don't have those because this is this flat area and we have channels, and that's basically pools and runs in our wetlands. And the North Oaks channels are functioning like that. It's a run of water. So I wrote the Lambert Lake monitoring site, and when I came to pick up the pack, I wrote the same things: temperature, or air and water, one pack retrieved, and the date. What type of leaves did I put in? This was all oak leaves that I put in the pack. And environmental factors are just some accessory information. I did, no storms occurred, no flooding, and there was no drought at this time. This part about sun and shade is not on the Monitor My Water website, so you could skip that, but I like to keep track of this, so I put 100% sun at this site because there's no shade cover throughout the day. The precipitation and placement, that's where I go to the resources on the side here, Weather Underground /history, and in that 3-week time period I can add up the precipitation and add that there. So that's all the prep, the nuts and bolts before. Once that's done, it's all the count. So what did I get this time? We have mayflies. I did not see caddisflies or stoneflies. 6 dragonflies, 3 damselflies. I had 6 of the riffle beetles, and everything else is none. So I'll mark zeros in that just to be clear. And then these are really common. The crustaceans, scuds, sawbugs. Bigger numbers there. A couple leeches and a couple of snails. You'll notice the snails are divided into what's the left-handed and the right-handed. Lunged snails are more sensitive to water pollution, and gilled snails are not. And we have that one here as our sample. Okay, so with that wraps up the data. I'm going to clean this up and bring everything back to the water body. Thanks for watching. I am available for questions. I want to make this an easy process for anyone who wants to volunteer. We'll try to boost confidence and make it something that's fun, approachable. It really is interesting, and there's a lot of stuff we learn from it. The impact will be lots of these packs over a few years, over time. Again, because you might not get every single organism, the trend is what we see after a few years of 4 a year, 3 packs a year, whatever you can do. But because each one on the website assigns a water quality value to that leaf pack, then they might vary a little bit, but what we'll use is the trend. This is a supplement to Vlamo's chemistry data, where we do our samples and take them to a lab, and we analyze all those details really closely. So being a supplement with the biomonitoring of living organisms, that's just something that complements, and the trend will really show another angle on that. So yeah, I'm excited and hope you are involved. And thanks for the interest. Okay. And one more quick note, this is our cleanup. So after everything went into the bucket, we have all my stuff ready for washing, rinsed out, and I'm going to leave the diagram map placemat out to dry. And we have the pack and the bag pouch that I used to collect that. I want to just add how it's important to collect the packs in a way that puts the bag underneath the pack right when you pick it up out of the water. If I were at the stream, I pick up the pack from the stake, from the rebar, and when you pick it up, organisms could be swimming out, and when that water's draining out and splashing and hitting the water, something's being lost in the data. So I like to gently pick it up in one smooth motion. Some things might swim out as soon as you touch it, but right when you have it at the surface, I scoop the bag underneath the leaf pack and then pick the bag up with the water, and then I've got everything that might swim out contained. The neat things are what's going to swim out. Your dragonflies, the megalopteras, the damselflies, things that are good at swimming are often the quality data that has significance to that water quality index. Okay. Thank you.